because I don't have that much to talk about. Okay, so anybody know what engineers do for a living? Like,
they make stuff.
They do. They make stuff. Anything else?
They make good decisions on whenever their product is safe or not.
Okay.
Not,
yes.
It's kind of like they're judges, and you know. Oh, and do you make flying cars, by the way?
Not yet. There are a couple of people that do.
Can you please lower the price? Because I definitely want to get that.
So do I. I don't have $250,000 for one, but I want one too. Yes.
They like make stuff work, like how they make cars work and lights on and off, and
Right.
like construction vehicles go.
Okay.
And stuff.
Part of what they said, and also do
is they design new products and new processes to try to make the world better, make things easier for you. So if you were to think of something like this computer, several different kinds of engineers would work on that. You'd have a computer engineer who would design the computer itself and how it works. You would have a civil engineer who would design the factory and the building that they build the computer in. You would have a mechanical engineer who designed all the tools and the machinery that they used to put it together. And you would have an industrial engineer who designs the flow through the factory and the way that things go together. So, there's 4 different kinds of engineers, and there's probably a whole lot more that go into just building this one thing. They all do a different part of it. And so there's lots of different specialties that you can get into with engineering. You just find the one that makes sense to you and that you enjoy, and you can go in that direction. And see do you like the job? Do you want to do that when you get out of school? And lets them see if they want to hire you when you get out of school. So I worked lots of internships when I was in school, and then I've worked a few jobs since I got out of school. I've worked in oil, I've worked on airplanes, just trying to figure out where it was that I wanted to be. So my first job, I worked in a gas plant in Texas, and I worked here in Oklahoma City at the Devon office. I spent that summer working in a gas plant, trying to figure out, what do you got?
I want to say something and I have a question.
Okay. So they can be built on time, so they can be delivered on time. Because there's only 2 ships that can do it, you got to really work well as a team and communicate, because if you miss your window with that ship, it could be several months before you get another one. So being an engineer, communication is very important. We talked about how you need to take a lot of math and science. You also need to be really good with writing, because it doesn't matter how cool of a thing you develop or design, if you can't convince somebody that it's the coolest, it's not going to happen. So you got to be able to write really well and convince people that what you're doing is the right thing.
Did you have some exciting times going out to oil rigs or working out in the ocean?
I never got to go to a rig. I worked in design, and then I worked in 2 factories. I worked in a factory in Louisiana where they built these, and I worked in a factory in Louisiana or in Germany where they built the control systems.
So if you're an engineer, it's a little less dangerous and dirty than if you were working on the rig?
There are your drilling engineers who are out on the rigs. That is one thing you can do in oil. You can be a drilling engineer who's out on the rigs and helping them make sure that they're doing everything right and they've designed their drilling process appropriately. Or you can be like me. I am a design and structures engineer, so I work on this stuff to make sure that it's not going to break when it's a mile deep and it's got all that water pressure piling in on top of it, that it's still going to hold together. You put this mist out into the room and it should choke out the fire and not let it breathe anymore, but it wouldn't hurt any people or any computers that are in there. It shouldn't fry any electronics. And we worked on a high expanding foam that should get in there and be really bubbly, so it shouldn't be too wet, but it could still put the fire out too. And so those were things we were working on, because right now what they use on a lot of places to put fires out is a gas called halon. And halon, will flood the room and push all the oxygen out, but then a fire needs oxygen to keep burning. So it'll choke the fire out and it'll go away, but it's bad for any people that are in the room. So if they don't have an oxygen mask, they're going to be in trouble. So we're working on trying to come up with something better than that, so you can, 1, not hurt the computers because they cost a lot of money, and 2, not hurt people. Yeah, improve bad designs and make them better so it'll last longer, and just try to keep things flying. And so I work on the B-52 and the B-2, The B-52 was originally designed and built in the 1950s. And they're going to try to keep them flying until 2040. So it's a very old airplane. It takes a lot of work to keep them in the air. And then the B-2, if any of you have ever seen that, it's the stealth bomber.
Yeah.
Really cool looking airplane. It's made out of composite, carbon fiber. That helps it to absorb some of the radar. And so what we do is we take, old airplanes were built in the 50s. They didn't know as much about metal as we do now. And so a lot of the metal was bad for fatigue. So if you ever bend a paperclip, you can bend it once and it's fine. But you bend it 5, 6 times, it breaks. That's called fatigue. So and it can stand up to a load 1 or 2 times and it's okay. But the more times you keep doing it, it eventually gives up and it breaks. And so there's a lot of metals that they used back then they didn't realize that was a problem with. And so now we've got better ones and we're using that to replace it and fix them.